Welcome. In this explainer, we're diving deep into PC Guard's security settings. If you're a developer, think of these settings as your toolkit for building a fortress around your software. We're going to walk through how to configure them to really lock down your application.
So here's what we've got on tap. We'll kick things off with application integrity, the basics. Then we'll stack on layers to prevent reverse engineering, secure your licensing, and finally, we'll touch on some really advanced protections. By the end, you'll see how it all fits together.
You know, every single setting we're about to look at plays a part in what's called the security posture of your software. It's all about combining these individual options to create one seriously tough defense against anyone trying to modify, crack, or misuse your app.
First things first, let's talk about integrity. How do we make sure your application file is exactly as you intended it to be? This is the foundation, really, because if someone can mess with your executable, well, all the other protections could be at risk.
Right out of the box, the first line of defense is self-checking, and it's on by default for a very good reason. Your app is constantly checking its own encrypted code, making sure nothing's been tweaked. If even a single bit is off, the protection code knows about it instantly.
So if a self-check fails, what's going on? Well, it almost always boils down to one of these three things. Someone is actively trying to patch your app, there's a conflict with another protected application using the wrong keys, or in some pretty rare cases, the operating system itself is making changes on the fly.
Now, if you want to get even stricter, you can flip this switch. This goes beyond checking the internal code sections and instead validates the entire executable file. If anything is different, and I mean anything, the application just stops dead in its tracks and refuses to run.
But here's the crucial thing you have to remember. This is a final step. You only turn this on after you've done everything else, like digitally signing your code. If you do it too early, you're going to lock yourself out from making any more changes. So save this one for last.
Okay, so we've secured the file itself. The next step is to make life really, really difficult for anyone trying to pop the hood and figure out how your application works. The goal here is simple. Make reverse engineering a massive headache. This one is a classic, and it's on by default. PC Guard is constantly on the lookout for debuggers. If it senses that one has been attached to your app's process, it just shuts down. It's a simple but incredibly effective way to stop analysis before it even starts. Honestly, you should probably never turn this off unless you have a very specific niche reason. Maybe you've got a protected DLL that's being called by another part of your program that you need to debug. But for most cases, just leave this on. It's doing its job. And here are 4 more ways to throw wrenches into the works for reverse engineers. You can detect API hooking, which stops other tools from intercepting function calls. You can enable anti-dumping to prevent them from taking a snapshot of your app's memory. And of course, renaming sections and erasing import data are great ways to just, well, confuse the heck out of their analysis tools. All right, let's shift gears and focus on the license itself and the environment your app is running in. We need to make sure a valid license is being used correctly and that no one's trying to trick the system to get around any limitations. This setting is pretty clever. It directly connects the integrity of your app to the license. It performs what's called a cyclic redundancy check, or CRC, during decryption in memory. Think of it like a very sensitive digital fingerprint. If that fingerprint doesn't match, a huge red flag for tampering, it doesn't just crash, it automatically kills the license. So here's exactly what that looks like in practice. The CRC error is found, the user gets a file damage message, and in the background, poof, the license is gone. This means they have no choice but to get a fresh, legitimate activation code to get the software working again. This one is another proactive measure that's on by default. If the license file itself looks corrupted or tampered with, this setting doesn't mess around. It just deletes the file. This is great because it prevents the app from even trying to load bad data and pushes the user toward a clean reactivation. And what the user sees is this clear, straightforward message. It tells them exactly what the problem is, the license data isn't trusted anymore, which explains why they need to reactivate. It's a really clean and secure way to handle a failure. The old turn back the clock trick to extend a trial period. This setting is designed to stop that cold. When you enable it, PC Guard gets way more strict about checking the system time. If it sniffs out any tampering, it can just reset the demo or the limited license, completely neutralizing that attempt. Okay, let's get into the advanced stuff.
These options are for dealing with more specific threats and give you tight control over the actual environments where your application is allowed to run. Runtime encryption, or RTE, is a seriously powerful feature. It lets you pinpoint the most critical parts of your code, maybe a custom algorithm or a key validation routine, and keep them encrypted even while your app is running in memory. They only get decrypted for the split second they need to execute, and then they're immediately encrypted again.
Now, this is super important, so pay close attention. If you have a group of applications that all share the same license file, you have to be consistent. If even one of those apps uses RTE, you must enable the RTE-enabled setting for all of them. If you don't, the other apps won't be able to decrypt the shared license and they'll fail. This table lays out some really useful environment checks. You can choose to block your application from running inside a virtual machine, on systems with software like Deep Freeze, or even when analysis tools like Process Monitor are running. You can also block remote desktop sessions. They're all off by default, giving you the flexibility to turn them on based on what you need to protect against. All right, let's wrap this up and recap the key points. At the end of the day, how do you take all these settings and build a smart security profile for your application? If there's one thing you take away from this, it's this. Think in layers. There's no single magic button. A really strong security strategy comes from combining these different protections: file integrity, anti-analysis tricks, solid license security, and tight environmental controls. You get to mix and match to build the perfect defense for your specific app. So, as you go back to your project settings, think about what you're trying to protect. By layering these options, from the basic self-checks all the way up to advanced features like RTE, you can create a defense that is smart, tough, and tailored perfectly to your needs. The only question left is what combination is right for you.